Hello, everyone. Welcome to examples for chapter 8. We have made it to the last chapter we will cover in this class. I hope you guys have learned a lot throughout this course. And let me tell you what we have left to do in the semester. We will cover this chapter. There are 3 sections. In section 8.1, we will learn what a hypothesis testing is. This is a process that consists of 8 steps. And we will learn the general idea of what that is. Then in section 8.2, we're going to do hypothesis testing for proportions specifically. And then in section 8.3, we're going to do hypothesis testing for means. Okay, that's basically it. We will have 3 assignments for this chapter, and we're done. Then we'll have a couple of quizzes to review before the final, and then we will have the final exam. So let's get started. I want to show you one example with a proportion, one example with a mean, and then another question that deals with types of errors. So question number 6, this is from the assignment of section 8.1, 8.2, day 2P. Oops. Let's read first. Suppose that in a random selection of 100 colored candies, 24% of them are blue. The candy company claims that the percentage of blue candies is equal to 22%. Use a 0.01 significance level to test the claim. So basically, the first 3 steps is the question we have in front of us right now. We need to come up with the null hypothesis and the alternative hypothesis. The null hypothesis always has an equal sign. So null hypothesis is denoted by HO. So this could be the null hypothesis because it has an equal sign. C cannot be correct because the null hypothesis, HO or H nil, has to have an equal sign, and this one doesn't have an equal sign. So this is not the answer. So that is one thing we have to consider for the null hypothesis. And then for the alternative hypothesis, it's going to depend on what we're trying to prove. If our claim is that the proportion is greater than some value, our alternative hypothesis will have that sign in the equality. If we want to prove that the proportion is less than some other value, the alternative hypothesis will have that sign. If we are just saying that it is equal to something or it is different than something, then it's going to have that sign. So in this case, it must be option A. So that's basically the first 3 steps. Let's quickly summarize what we did. Null hypothesis always is an equal sign. And then the sign on the alternative hypothesis is going to depend on the claim we're making in the prof. Okay. And notice the number is always the same. In this case, it comes from the 22% we had up there. Step number 4 is simply identify the significance level. So here we have 0.01. That's alpha. And that's going to be useful in step number 7. But right now we are in step number 5. So we need to calculate the test statistic. So we have a formula for this. Let me show you very quickly. On this slide right here, step number 5, we identify the test statistic and determine the sampling distribution. So in this case, we are working with a proportion. So the test statistic is this, p hat minus p over the square root of pq over n. Let's write that here. Test statistic is p hat minus P over the square root of PQ over N. Okay, so P hat, remember, comes from the sample. This is the sample proportion. So we are being told what the proportion is in the sample. It is 24%, so, or 0.24. N also comes from the sample. N is the sample size. We are told that the sample size is 100. And now this is important. P and Q are values we don't know. Those are the values we are trying to estimate. So for this step, we assume that P follows the condition given in the null hypothesis. So we will assume that P is equal to 0.22. So basically what we're trying to do is we make this assumption, and then we're trying to find out if that makes sense or not. So that's kind of like what we're doing. So let's find the test statistic here. P hat, that is 0.24, that is from the sample, minus P. We assume it is 0.22 according to the null hypothesis. Then we divide by the square root of P, which is 0.22, times Q. Remember, Q is always 1 minus P, so that is 0.78. And then we divide by the sample size, which is 100. So let's find this test statistic. Zero point 42, rounded to 2 decimal places. Perfect. So that is step 5. We calculate this test statistic. And then we identify the p-value. Now for the p-value, we will use technology. So we go to MATLAB. We go this menu on the left. We go to StatCrunch. We open StatCrunch, which is here. And then what we do is we go to Stat. Then we go to Proportion Stats, one sample with summary. And then we basically just plug in the values that we have in this problem. Number of successes. Notice we don't have that in this problem. We want to know how many of the candies are blue. We are not directly given that number, but we can find it because we know that 24% of 100 candies are blue. So we multiply 100 times 0.24, and we get 24 successes. Number of observations means sample size. How many candies did we look at? Hypothesis test, notice by default, P equals something. So we change this value. In this case, our null hypothesis is 0.22. You can go back if you forget what it is, 0.22. And our alternative hypothesis is P different than 0.22. So notice we can also change that. It depends on the problem, what sign we will use. And that's it. We compute and we get this result. And what we want to pay attention to is this value here, the p-value. Step number 6 is finding the p-value. So that is 0.6292. That is the question we had here. The p-value for the hypothesis testing is 6292. Oops. P-value. This is a good time to remind you guys, always read how many decimals they want you to round. 2. Okay, so far so good. We know how to do this. Then we move on to step number 7. Let me remind you, step number 7 is basically deciding whether we reject the null hypothesis or we fail to reject the null hypothesis. And how do we do that? We compare that to our confidence level. If the p-value is less than or equal to the confidence level, we reject the null hypothesis. If the p-value is greater than the confidence level, we fail to reject the null hypothesis. In this case, remember our alpha confidence level is 0.01 and our p-value is 0.629. So the p-value is clearly greater than the confidence level. So that means that we are going to fail to reject the null hypothesis. And with this, we need to go to step number 8 and restate the decision. This is like kind of like hard to memorize. This will be included in the formula sheet for the final. So don't worry about memorizing this table 8.3. And then we need to identify which one of these 4 conditions we have so that we can state the conclusion for our problem. So in this case, the original claim includes equality and you fail to reject the null hypothesis. What does original claim includes equality mean? Let's check the claim. The original claim is that the percentage of blue candies is equal to 22%. So that is what includes equality mean. Like we have that, we want the proportion to be equal to a number. If that is the claim, then we have this case. Original claim includes equality. If that is not the sentence we have, then original claim does not include equality. Okay. So for this problem right now, we are in case number 4. Original claim includes equality, and you failed to reject the null hypothesis. So we want to look for a sentence that looks like this. There is not sufficient evidence to warrant rejection of the claim that original claim. So let's take a look at our options. First of all, we have to say if we reject or we fail to reject. We fail to reject, so it is either B or D. And there is not sufficient evidence to warrant rejection of the claim that the percentage of blue candies is equal to 22%. That's that. And remember, we are including this table in the formula sheet. So you have it on your notes as well. So you can use it on your notes for your assignments and for your quiz. And you will have it on the formula sheet for the final. So you don't have to memorize this. Okay, we're just comparing the correct sentence for our conclusion. And that's it. So that is problem 6 from this assignment. That is the whole process, the whole 8 steps. That's what we just did. That is this for a proportion. And now I want to show you an example for a mean. So let's go to that assignment. Assignment 8.3. Question 1. Many steps are pretty similar. I think 1 through 4 and 7 and 8. And what's going to change is for step 5, we will use a different formula for our test statistic. And for the p-value calculation, we're still going to use StatCrunch, but there is a different option we click somewhere along the way. And that's it. So let's do question 1. A data set includes data from student evaluations of courses. The summary statistics are n equals 84, x bar equals 3.32, and s equals 0.61. Use a 0.10 significance level to test the claim that the population of student course evaluations has a mean equal to 3.50. Assume that a simple random sample has been selected. Identify the null and alternative hypothesis, test the statistic, p-value, and state the final conclusion that addresses the original claim. Okay, so for the first part, we need to identify the null and alternative hypothesis. The claim is the population of student course evaluations has a mean equal to 3.50. This is equal as well. Let me see if we can do a different one. Let's do this one instead. Question 2. It's basically the same process, but we already did an example with equal. So in this case, it's less than. A data set about speed dating includes like ratings of male dates made by the female dates. The summary statistics are given. Use a 0.10 significance level to test the claim that the population mean of such ratings is less than 8.00. Assume that a simple random sample has been selected. Identify all these things for the hypothesis test. So first, we need to identify the null and alternative hypothesis. Remember, the null hypothesis is always equal to, and then for our alternative hypothesis, we wanted to match the claim. So in this case, less than 8. So it has to be option D. Alternative hypothesis is less than, and null hypothesis is always equal to. Now we need to find our test statistic. So again, we can go back through the notes. We have the formula for that right here. X bar minus mu over S over the square root of n. If you remember, this is a formula we used in chapter 6 whenever we were using the central limit theorem. But okay, so our test statistic is X bar minus mu, which is the population mean, over the standard deviation, which is sigma, over the square root of the sample size. So in this case, X bar, we are told is 7.55. That comes from the sample mean. Mu, again, is a value that we don't know. We're trying to estimate what that value is. So we are making the assumption that it is the value we are stating in our null hypothesis. So we take that value for mu. So in this case, 8.00. Over the standard deviation, which we are told is 2.06, over the square root of the sample size, which we are told is 185. So let's plug these values in the calculator and find our test statistic. Negative 2.97 when rounding to 2 decimal places. So that is step number 5. We skipped step number 4, so just let me state that step number 4 is identifying the significance level. In this case, 0.1. Determine the p-value. So again, we're going to use the StatCrunch. But now instead, we always start here, stat. But now instead of using proportion stats, that's the option for proportions, we're going to go to t-stats. That's the option that we want to use for the mean. We select one sample as well, and we select with summary as well. So the sample mean, we are told is 7.55. The sample standard deviation, we are told is 2.06. And the sample size is 185. Yes. The null hypothesis is that the mean is equal to 8.00. And we want our alternative hypothesis to be that mu is less than 8. So notice this is the difference, right? This is the alternative hypothesis we have for this problem. So we need to change this symbol accordingly in StatCrunch. And then we compute. We're given some results here. And the p-value is right here. Notice we are also given the test statistic StatCrunch. So if you want to check with this, or maybe even skip the calculation altogether and use the result. That's allowed. But anyway, here's the p-value. This is the only way to learn to find the p-value. So we just copy it, 0.0017. 0.0017. We are told we want to round to 3 decimal places, so this becomes 0.002. Okay. And then we want to compare this value to alpha. And if this p-value is less than alpha, we reject the null hypothesis. In this case, 0.002 is less than 0.10. So we reject the null hypothesis. And then for the final conclusion, we go back to table 8.3, which again, you don't have to memorize. You can just look at it from your notes. And you need to identify the correct case you're working with in this problem. So in this case, the original claim does not include equality, and we reject the null hypothesis. So it is the first case. So the conclusion needs to look something like there is sufficient evidence to support the claim that. So here we have, there is sufficient evidence to conclude that the mean of the population of ratings is less than 8. Notice that is the original claim. In the original claim, the claim from the problem, we're saying that the population mean of such ratings is less than 8. And that's it. So maybe at first, when you look at the notes and you see all 8 steps, it might seem a little daunting. But once you get the hang of it, we also have StatCrunch, which helps a lot. It's not that complicated. So I hope you are able to do this without any issues. And I just want to show you one more question, which delves into error types. So this should be here, question number 2. Identify the type 1 error and the type 2 error that corresponds to the given hypothesis. So remember, that means, what are these? Let me just explain it briefly. A type 1 error is the mistake of rejecting the null hypothesis when it is true. And type 2 error is the mistake of failing to reject the null hypothesis when it is false. So we are either going to reject or fail to reject the null hypothesis. And the null hypothesis could either be true or false. So if the null hypothesis is false and we reject it, that's good. That's a correct decision. If the null hypothesis is true and we fail to reject, that is also good. That is the correct decision. But we can make an incorrect decision. So whenever we reject the null hypothesis, but the null hypothesis is true, we call that a type 1 error. And whenever the null hypothesis is false, but we fail to reject it, we call that a type 2 error. So let's use this to answer this question. So the claim is that the proportion of people who write with their left hand is equal to 0.23. So what is a type 1 error? That would be rejecting the null hypothesis when that is actually true. So let's try to look that in our options. Reject the claim that the proportion of people who write with their left hand is 0.23 when the proportion is actually 23. So notice this describes exactly what we have in the definition of a type 1 error. We reject the fact that that proportion is 0.23. So we're saying that's not it, but it is actually it. So that is the error, okay? That is a type 1 error. And what is the type 2 error? Type 2 error is failing to reject when that is false. So we fail to reject the claim that the proportion of people who write with their left hand is 0.23 when the proportion is actually different from 0.23. Again, maybe it can get a bit confusing with the wording, but this is what we're checking. We are failing to reject the claim. The claim is the proportion of people who write with their left hand is equal to 0.23. And the actual proportion is different from 0.23 because the null hypothesis is false. And that's it. So I hope that was helpful. And remember, if you have any questions, please let me know. I will be happy to help. And remember, we also have SI sessions you can attend Tuesdays at 5 p.m., Thursdays at noon, and you can also sign up for one-on-one tutoring if you would like that. But yeah, that's it. Have a good one.